All right, we are going to try this out. My husband allowed me to borrow his iPad and his Apple Pencil. I have not liked my handwriting on the others. I feel like I'm writing like I am a 6 or 7-year-old. So hopefully this will kind of clean up my handwriting a little bit. I do have a hard time because I like to hold my hand down. So we might still have issues with erasing and changing colors. We'll see how that goes. Okay, so we're on 6-2. I already did it. 6-2. Okay. And we're going to start doing partial derivatives. Okay. So there's no XL in this section. Okay. So partial derivatives. Okay. So we had f prime of x is the derivative. And we had dy dx is implicit differentiation. And then when we do partial derivatives, we're going to have d lowercase x. Oops, sorry. My bad. I meant f lowercase x and f lowercase y. Those are what we're going to use for partial derivatives. So hopefully we have a good handle now on implicit differentiation. All right, so our first problem. We're going to do example 3. F of x, y equals x squared plus 2xy plus 3y squared minus 4x minus 3y. And it asks us to evaluate x, 3.5, negative 0.5. Okay, so to do the partial derivative, this will be the one time I write it out long. We're going to do f lowercase x subscript x of xy. Yeah, we'll write it like that. And then I'm going to put the whole thing in parentheses. X squared plus 2xy plus 3y squared minus 4x minus 3y. And what it's going to ask us to do is it's going to ask us to only take the derivatives when we're looking at any term in regards to x. So we're only going to take the derivatives of x. So we have this one, we have the first part of the product rule, and we have this term. So f subscript x is going to be, the derivative gives me, oops, I already see a mistake here. This isn't that. It is x squared, sorry, is 2x. And then the first part of the product rule gives me 2y. And then I get minus 4. Okay. So I only need the first part of the product rule because that's the only part where I'm taking the derivative of x. All right. And then I need to evaluate it at 3.5, negative 0.5. And when I plug that in for x and y, I get 2 times 3.5 plus 2 times negative 0.5 minus 4, and I get 2. Okay, so I'm going to do the same thing for y though. Okay, so I'm going to do x squared plus 2xy plus 3y squared minus 4x minus 3y. And this time I'm going to only look at the y terms. So I just need this part of the product rule, this term, and this term. And when I take the derivative, so the 2x stays the same, I get just 1 for y plus 6y minus 3. So it's okay that I get x's and y's in my partial derivatives. I just need to make sure that I only take the derivatives of x when I take the partial of x, and only take the derivatives of y when I take the partial of y. So again, I'm going to evaluate this at 3.5, negative 0.5. So I would take 2 times 3.5 plus 6 times negative 0.5 minus 3, and I get 1. Okay, so we're gonna get down to making this a little bit easier and see where we're going with this, okay? Actually, this is example 2. Now that I look at my paper, sorry about that. All right, so my handwriting definitely got better, so let's see how the next page goes. So we're gonna do example 3. Oh, before we do example 3, sorry. Let me get rid of that. I need to give you an equation. This is what we're gonna need. It's called the tangent plane. All right, so the tangent plane, this is a linear function at x, y equals, so I actually just calculated f sub x at x naught, y naught. And you'll see how this happens in a minute if you don't quite get that. X minus x naught plus f sub y, x naught, y naught, y minus y naught, plus, you got to plug it back into the original function. Okay, so now we're going to do example 3. And in the end, one of the things we're going to do is we're going to plug it into that equation. Example 3. Here's our Cobb-Douglas problem. Okay, so now we have 10 L.75 C 0.25. And they're going to give us 2 coordinates. P sub 1 at 8116 and P sub 2 at 8514. All right, we're not going to use 8514 until the very end, so I'm going to put it in this yellow box so that we're going, hey, I'm going to use this, but not yet. So the first thing I'm going to do is, I like to do it in the order that it comes in terms of this expression up here. So I'm going to calculate the partial derivative with respect to x. So the partial derivative, which we normally do with respect to x, and if we're going to do the wording right, we're actually going to do the partial derivative with respect to L. Okay, if you use x and y, that's fine. When we get to the quiz and or test, I will use x and y. It gets a little confusing otherwise. Okay, so I'm only going to do the L piece of the product rule. So the 0.75 comes down. So if you need to, 10 times 0.75, L to the negative 0.25, C to the 0.25, and that simplifies to 7.5. And you can leave the negative in this, L to the negative 0.25, C to the 0.25. All right, so we're also going to do the partial with respect to C. So that's this back piece. So again, the way that most of us have done this, we're going to do 10. We're going to leave the L alone. And we're going to bring the 0.25 down. And subtract 1 to get negative 0.75. And to simplify, I'm going to move the 0.25 up front times 10. L 0.75. C negative 0.75. Okay, so the first thing they're going to ask you to do is find the partial derivatives. The second thing we're going to do is then plug in the partial derivatives with this coordinate. So let's take coordinate 1 and plug them in. So partial derivative with respect to L of 81/16. So 7.5, type this all in your calculator, 81. So the negative 0.25, 16 to the 0.25. And I get, let me see where I have it on my paper. I actually get 5 out. It's an actual nice number. All right, so let me do C. Still doing 81/16. 2.5 times 81, this time to the 0.75, 16 to the negative 0.75, and this time, I can't remember if I round or not, but I wrote 8.4375. Okay, so I was calculating this. Oops, I missed a parentheses here. All right, so this is f of x, x sub y naught. And this one is f of y, x naught, y naught. Let's see if I can squeeze it in there. Got it. All right. So going back to the line at the top, I have the first two pieces, but now I need, too bad I don't have another color, but let me use black underline. I need to find this piece. I need to find the original function at x naught, y naught. So I'm going to take P and evaluate it at 81/16. So go back to the original function. So we're going to take 10, L is 81, to the 0.75, and 16 to the 0.25. And I get 540. Okay, so again, this one now is f of x naught, y naught. All right, the only thing that I really haven't identified for you yet is that 81 is x naught and 16 is y naught. So we're going to take all of these pieces and put them into one equation. Okay, so new whiteboard. So you can either do P of LC or X of, or F of XY. It doesn't bother me one way or the other. Okay, so if we go back to the other whiteboard, it says to take 5. That's the first piece. I wrote it in red. We're going to take 5, x minus x naught. Well, x naught is 81. So I'm going to write that. 5x minus x naught, which is 81, plus, now let's do the next part. We have f of y, 8.4375, y minus, what did I plug in for y? I plugged in 16. So 8.4375 y minus 16. And then the last piece is what is the number when I plug it into the original function? So it's 540. So that's my equation of the linear plane. And I will give you this equation on a quiz and or a test. So I write it so you don't have to go looking for it. So this equation right here, I will give it to you. The whole equation. It's written on the bottom of the page if you need it. If you don't need it, then I don't give it to you because that's confusing. This can be confusing if you don't know how to use it. So make sure you do know how to use it. Okay, so I did go in order of how it's written. So notice that we plugged this in first, then we plugged this number in, and then last but not least, I plugged this number in. So I kind of do it in an order, so it's much easier to plug into your formula. Okay, the last thing example 3 asks you is to go back to that one piece that we left. Hey, don't forget about this guy right here. We need to plug in 8514. They want to find out what the approximation is when I plug it in for a new coordinate. So we're going to put 8514 into our function. So what is, I don't really want to use yellow. What is it when I plug in 8514? So 85 minus 81 plus this 8.4375, 14 minus 16 plus 540. Okay, so I need to plug all that into my calculator. I would make it 4 times 5 plus 8.4375 times -2 plus 540. And my final answer is 543.125. Okay. So the last problem we're going to do, I'm going to kind of show you how it goes all the way down on a classwork and on a homework problem. Okay. The derivatives are a little bit trickier than I would expect you to be able to do on a test or a quiz, but it's not bad for us to look through. Okay. So let me get a new whiteboard. And we're looking at number 3 in the textbook. Okay, so we have x squared times x plus 2 to the y. They give us the first coordinate is 3, -1. And the second coordinate is 3, 0. So if you want to, while we're doing this problem, you could pull up the textbook to look at the actual instructions for this. Okay, so what it asks for on part A is for us to hold one of the terms constant. So hold on, let me kind of box off in yellow that second coordinate. Let's not touch it. So the first thing it wants us to do is hold one of these numbers constant. So it's going to ask us to hold 3 constant and leave y alone. And then it's going to ask us to hold x constant and plug in -1. And we're going to simplify. So that's what it's asking. Put in the x coordinate, leave y alone, put in the y coordinate, leave x alone, and we're going to simplify. So I'm going to get 3 squared times 3 plus 2 to the y. That simplifies to 9 times 3 plus 2 to the y. That's all I get. That's your answer for that one. On the second one, I get x squared times x plus 2 to the -1. So I do need to simplify that a little bit. X squared times x plus, that becomes 1/2. And then the textbook asks us to multiply that out. So we're going to get x cubed plus 1/2 x squared. So that's part A. Part B is going to ask us to take the partials. So we're going to take f sub x. And this again is a little tricky. So we're going to do the product rule. So here we have f of x. Here we have, or sorry, yeah, g of x. So let me write that out. This is f of x. This is g of x. All right. So when I take the derivative, so both of them have x's involved. So I do have to do the full product rule. So I'm going to take f of x gives me 2x. And the back stays the same. Plus the front stays the same. And I need to take the derivative of the back. So I get 1 plus what happened on the other pages when I took the partial derivatives was they just didn't go, they just dropped off. So the way that they dropped off was that they turned to 0. So anything with a y term, when I take it and I'm doing a partial derivative, turns to 0. So I am going to simplify this a bit. I'm going to get 2x squared plus 2x, 2 to the y, plus this back term turns to x squared. So I'm going to get 3x squared plus 2x, 2 to the y. It's going to be much easier to plug something into that. All right, so to do the partial with respect to y, this one will become a little bit easier if I simplify fxy into something easier. So let me write it a little bit smaller here for you in green. So fxy can turn into x cubed plus x squared 2 to the y. So I'm going to deal with that. So if I'm going to take the partial derivative with respect to x, or sorry, with respect to y on this one, I don't worry about the first term. And on this one, I'm only going to worry about the second half of the partial derivative because it's the only one with respect to y. So I only need to do the fg prime. This is why this is tricky and why I wouldn't expect you to do it on a quiz or a test, but it's not hard for us to think our way through it. So if I have f, I just get x squared, and 2 to the y becomes the natural log of 2 to the y. Okay, so that's part B. Part C asks us to plug in 3, -1 into our partial derivatives. So if I do it for 3x squared, I get 3 times 3 squared plus 2 times 3 times 2 to the -1. So make sure you plug it all the way in correctly. You should get 30. Then we're going to do the partial with respect to y of 3 -1. So I get 3 squared, natural log of 2, 2 to the -1, and I'm going to round this to the nearest hundredth, so I get 3.12. Okay, let me mark these again for you. So I did red on the other page of this one, and I believe I did blue on the other page of this one. If not, it is now. All right, so part D. Let me go to new whiteboard. Part D asks for the tangent plane. But we're missing one piece. We're missing that f of xy. So remember, we're going to take f at 3, negative 1. So we're going to get 3 squared times 3 plus 2 to the negative 1. Okay, you plug that all the way in, you calculate it out correctly, and we get 31.5. So again, f of xy. We wrote that on the other page. All right, so the whole tangent plane equation. So f of xy equals, if we go back to the other whiteboard, again, we're going to do it numerically in order. We're going to take 30. And we're going to take x naught, which is 3. Let's use those two first. 30 x minus 3 plus, let's go back to the other page. Let's look at what we got. Now we're going to take 3.12 and we're going to take negative 1. Plus 3.12 y minus a negative 1. I'm a stickler. Change it to plus 1. There's no reason why you don't. And then the last thing, let's take 31.5 plus 31.5. So this is the answer for D. Part E is going to ask you to go back. Let's look at our numbers. Here's my friend, 3, 0. We're going to plug that in. That's the last step. So, oh, I don't want yellow. It's hard to see. F at 3, 0 gives me 30. 3 minus 3 gives me 0 plus 3.12. 0 plus 1 is 1 plus 31.5. My final answer is 34.62. So these ones take a little while to do. There might be 3 or 4 on the homework, but just make sure you get all the way through them. Take your time. It shouldn't be too bad. Let me know if you have any questions at all.